Hey guys, welcome to Max TV. In today's video, we will be looking inside an ultrasonic washing machine, diagnosing its fault and repairing it. My mom recently asked me to have a look at it after it stopped working and the power supply smelled like burning plastic. It's actually imported from Russia, has non-polarized European plug and rated at 220 volts, 50 hertz, 20 watt as you can see. Now I haven't been inside this power supply yet, but by the weight I assume that's a linear power supply. In Australia we have 240 volts at 50 hertz and sometimes actually tops at 260 volts, so I assume that could have damaged the transformer. I have also noticed that inside the second unit the plug is damaged, so if we have a look you can see that it's moving in and out. It shouldn't do that, and if you unscrew that it is completely broken. That may have actually shorted inside and shorted the device and blown the transformer. As you can see, it's completely broken off, so let me just fix that quickly and I'll be right back. The new plug has been installed. There it is, it's nice. And now let's have a look inside of this box together. I've already removed the screws, but haven't been inside yet. So I'm actually also thinking to help her out, because she's been using the Chinese death adapter for Australian plug. I've decided to put it in a nice, I've got a box here from, I think it was HP printer, to get all the insides and put it in this nice box and make a proper figure 8 adapter so she can just plug it in nicely and safely. Alright, so here it goes. Let's see what's inside. If I can, hang on, yeah. Alright. Alright, so we've got a transformer and the circuit board. Let's try getting this out. If I can. Alright, give me 1 second. I'm just going to desolder this and I will be right back. And I am back. So we've got the transformer out, we've got the board out. Let's put the transducers out of the way for now and have a look at the transformer first. So we're going to see if that transformer has actually failed, and that's what's causing. Let's go through to this one. Alright, let's check the primary. Okay. And the primary's got, yeah, it's not, hang on, let's see the resistance. 1.5 kilo ohm on the primary. Now let's check the secondary and see if there's something on the secondary. Oh, those tiny wires. And we got 16, hang on, that is confused, that is really hard to catch. 16 ohms on the secondary. Alright, I'm going to, let's plug that in and see if what sort of voltage is on that transformer, because it's unmarked and there is nothing on the box saying what voltage it's supposed to be. So 1 second, where is my cord? I will power it through a current limited supply through the variac, just in case. Let me just get that ready. Alright, so here it is. Let's go to voltage, AC, and slowly increase the variac. And it looks like transformers working just fine. So that's 120 volts and 240. The transformer's output's 25 volts. So it's 1 to 10-ish approximately. So the transformer is working fine. That's good. So that means something else is at fault on the circuit board. So let me just reverse engineer it. I'll shut that off. Alright, I have tested every single component on the board and I could not find faults at all. The capacitor is fine, there's nothing leaky. So here is a close-up of the board. It's very simple. It's got two transistors, NPN transistors, as you can see here. Two inductors. I can't tell the values and I can't really tell you much about transistors because they are Russian. And it's Russian lettering saying KT817G. So it's going to be really hard to find one without the without the data sheet for it or Russian keyboard. So the diodes are fine. The capacitor I've tested for leakage is absolutely fine as well. Very simple board. So I'm going to put it together. I'm not going to be using this case. It's just too dodgy. I'll probably keep the sticker and put it on the new case. That European plug is just a European plug, so there's no use for it in Australia. And I'm sure it'll be a lot more comfortable to use just a normal figure 8 cord, just like that. Alright, so I am going to put it together and then we're going to test it and see if it works. Alright guys, so after trying to build the washing machine, I've tested all the transistors and components, capacitors, everything was well. Yet once I turned it on, the transistors were getting quite hot. LED was off and I couldn't figure out what happened. Turns out it was the inductors. So inductors have melted inside and shorted out. So let me zoom in and show you. So I had to, unfortunately, because they don't have values on them and they shorted, so I can't probe them. So if we look close, you can see in the center they have melted completely. Right there. So I had to rewind them by hand. The easiest way to do it is to cut the wire off on the beginning side. Measure this, so I'll do it right now with the right tools. I will cut, let me see where it comes in. That's the end. So cut it right near the leg, right down there. There we go. So then measure the wire with the caliper. And this one is 0.12. So once you measure it, then the easiest way is to unwind the whole spool and cut it again right at the leg. Then measure the whole length of the wire and find the substitute wire, which is the first inductor that I've done, which is this one. It was a bit thicker, it was 0.19, so found some spare wire. And it was 176 centimeters, and I left 5 millimeters on each end, so 177 altogether. So 5 millimeters is you strip it and you wind it on the first leg. I'll show you in a second once I find the right wire for the second inductor. And then you wind it back up. So that's the easiest way to figure out the inductor if it doesn't have any values on it and it's shorted and melted. That's the best way, just to unspool the whole old wire, measure the thickness and the length and find the spare wire, do the same length and then wind it up by hand. Let me find the wire and I'll be right back. Alright, so I have finally found the wire, which I have found on another inductor laying around, so I took that off there. That's the original one. The length was 210 centimeters, so I've cut it at 211 centimeters, 5 millimeters on each end for the legs. So what I'm going to do is just tin the wire on the end. Because the wire is so thin, there is no point trying to strip it. Just use the soldering iron and that should melt the thin coat of lacquer that is on it. once you tinned it, just wrap it around the leg. Let me show you up close. Alright, so probably using tweezers for this. This is really small. Really hard to do without sticking my head under the camera. Alright, just like that. And solder it in place as well. Just tack it. Then there is a groove. Well, there is no groove in this inductor, but usually there's a groove. And now just start winding it and counting the turns. Now I'm not going to bore you with that process, but I'll just do that off camera and then I'll show you the finished result. Alright, so I did wind the coil. Pretty quick actually. It took me about 30 seconds. To be honest, I did cheat and I used this electric screwdriver. So now all I have to do with that little tail is tin it again. That's great. And wrap it around the second post. So once that's wrapped, we can now solder both of the ends properly. That's done. And that's done. So here's a new inductor ready. That's the old wire that I have there. And yeah, it's bad. It's melted all the way through. It's shorted, completely shorted. So here's a new inductor, and let's put it in the board and see if it works. So I'm actually really curious myself to see if that will work, but that's what I think has originally happened with that washing machine, is the output that we saw on that electrode or transducer, whatever that is, it's shorted, and that caused transistors to pretty much heat up and melted those inductors as well. So now let's see if it works. I'm just going to put it back in that little enclosure that I did. Zoom out. So let's attach the LED. All the components have been soldered, all the wires have been soldered. Clip those wires. That's all done, so let's plug it in and see if anything will happen. Here we go. Okay, the LED is lit, so that's a good sign. And I'm not sure how it tested. I can hear something. Oh no, I can actually feel the vibration, but only if I move my finger. So if I'm holding my finger on top here, nothing happens. But if I'm moving it right or left, I can feel sort of strange, I don't know, vibration, of almost like a transformer buzz, but yeah. Let me just get some water, and I'll bring some water and we'll see what happens if I'll put it in the water, if we see anything. Well, I'm not seeing anything physically, but let's get a scope and have a look if there's any frequency or anything's coming out from those outputs. I'll get my digital scope on. So the scope is on, and it does output quite an interesting signal. So let me just see if I can adjust the trigger. There we go. There. So it's pulsing at 43.4 kilohertz. At actually no, it's 14 kilohertz. Yeah, 14, 43, 28. Alright, so peak to peak is 17 volts. So I suppose that's working just fine. I guess my mom will be happy with the result. Alright, so here it is. Now I'm just gonna put it back together, clean off all the paint, and excuse the mess on the desk. This actually consumes 25 watts. Actually no, sorry, that's because the variac is on. Let me switch it from the variac to a normal power point, and I'll tell you exactly how much it's consuming. Alright, so it is 3 watts. Alright, thanks guys for watching the video. I hope you enjoyed it. Don't forget to subscribe and hit that like button, and I'll see you next time.